Now let us take the second example. In the second example, we are doing a math of the synchronous TDM in which we combine 20 digital sources, meaning that our number of the channels is the 20, and each of the channels, each of the digital sources are carrying 100 kbps. And now we know, now they have also said that each output slot, this is your frames, in each of the frames, and each output slots carries one bit from each of the digital sources. And so that means that in synchronous TDM, we know that the number of the channels is equal to the number of the frames, number of the slots in each frames. Using this formula, number of the input channel is equal to the number of the slots in each of the frame, that is going to be the n. So if we now we know that, so there will be 20 channels over here, 20 slots over here. Okay, so 20 slots. This would be in the normal cases, but now they are adding some extra information, and they have said but one extra bit is added to the each frame for the synchronization part. So now they have been adding one extra sync bits. So this is your sync bit. So let's say this, suppose that is at 1. So they are adding an extra slots at the end of the frame for the synchronization part. Okay, so basically each of the frame and your next frame will be looking, there will be 20 slots, each of the carrying one bit. So if I show you the bits, so this is your 1 0 something like this, 0 1, basically some random numbers we are assuming with a bit length of 1. And there will be, in the second case, this will be also 20 bits plus extra 1 bits for the synchronization part. Okay, and now we have to answer the following question. The very first question is straightforward. What is my size of an output frame in bits? Okay, what is my size of an output frame in bits? We already have solved this question because we have 20 bits from channels, plus we have one bit for the synchronization part, for the sync part. So now we know the frame size will be 21 bits. So this is your frame size. It would have been 20 bits if the synchronization bit was not added. So this is my frame size. Each of the frames is now carrying 21. Now let us do the second question. The second question says, what is your output frame rate? Now we know that the output frame rate has the two formulas. First formula is the input rate divided by the multiplexing unit. This is available. This should be applicable when you don't have the frame duration. And then if you had the frame duration, then you could also use the 1 divided by frame duration, the output frame duration, or 1 divided by T naught, because we know that the frame duration, the rate, the bit rate, the data rate, any kind of rate is inversely proportional of the duration or the vice versa. Now, in this case, we don't know about what is our output frame rate. We already know our input data rate. We don't know about the output frame duration. In this case, we don't know about any kind of output frame duration. We only know about how many frames, what is my size of the frames, how many channels we have, what is my input rate of each of the channels. So now we know, but we have another information. So we don't have any kind of frame duration. So this formula is not going to work here. Let us try this first formula, input rate divided by multiplexing unit. We already have the input rate over here, and then we know the multiplexing unit. As we can already anticipate from the output slot now carries one bit from each of the digital sources. That means we are gathering one bit from each of the digital sources. So basically this one, now we're gathering this part. Let me draw it another color. So this part we're gathering in this part because that part is corresponding to that part, that small bits over here. Now they are saying this means, so this is equal to 1 bit. So we already know that this is my multiplexing unit. So my multiplexing unit is also going to be 1 bit. So yeah, we already have the input channel rate. The input channel rate is now 100 kbps in these cases, 100 kbps, and then we have the multiplexing unit or mux unit as the 1 bit. Basically, we can use the first formula. Using the first formula, I'm going to use some kind of shorthand method. I'm not going to write the output. In some case, I would write the out frame rate. I hope that you could already understand the out frame rate is basically the output frame rate. So the out frame rate is input rate. Our input rate is 100 kbps, and then the multiplexing unit is 1 bits. So basically, now we have the 100 kilo frames per second. Okay, kfps, because the output frame rate, now it's frame rate means how many frames we are sending in 1 unit second. So basically those are going to be 100 kfps. So our question number 2 is done. Question number B is done. My question number C, what is my duration of the output frame? Okay, what is my duration of the output frame? We're using this formula. Now we can use this formula because now we know the output frame rate, and now we're going to find only the output frame duration, because using this formula we know that frame duration is the inversely proportional of the frame rate. So basically the question number C will be just inverse of this. Okay, we're going to inverse of this. So the output frame duration is basically the inverse 1 divided by out frame rate. Okay, 1 divided by out frame rate. So basically 1 divided by 100 kfps. Okay, so that is going to be, I think, 10 microseconds. That is going to be 10 microseconds. So now let's talk about the second one. Sorry, the fourth one. What is my output data rate? Okay, this question is a little bit interesting. We know that we have two output bit rate formula. The first one is if there is a no synchronization bit. If we didn't have any kind of synchronization bit, then we could say the output frame rate could be the n into the input rate, where n being the number of the channels, because there would haven't been any kind of overhead of carrying an extra bit or 2 bits or 3 bits or any number of the bits for the synchronization part. Could easily use that formula. But now we know that we are a little bit different than this case, the n into the input rate, because now we know that we are adding an extra bit for the synchronization. So the synchronization part is a little bit doing something different for us. So we cannot use the first formula. We have to go for the second formula. The second formula says whenever we have some kind of sync bit, that will be the frame rate into the frame size. Okay, and this formula also applies when there is no synchronization bit. Basically, we are asking the data rate of the output rate, how many frames are sending. The data rate will be that how many frames we are sending, and the number of the bits carried into this frame. So basically it's like that. What is my output frame rate of a production channel? The production channel is that the how many packets or how many packages it can wrap around within a particular unit of the time, and how many small compartments, how many packets will be there. So basically it's saying that if we have a large number of the packets, we are going to, if we're going to have a large number of the packets and we're going to packetize them, is get what is my, how many frames or how many packets, how many packages or how many cartoons I can make, I can wrap around in 1 second, and how many things I can put here into each of the frames or each of the packets. So basically the idea is very simple. How many frames you are sending and what is the size of your frame. So the output data rate is basically, now this is basically how many frames you are sending in 1 unit second. So that is my output frame rate, and into the number of the slots, or the number of the, yes, basically the number of the size of the frame is basically number of slots inside the total slot inside the frames. So the output frame rate, we know that this is 100 kfps, and the frame size from the question number 1 we already know That is going to be the 21 bits. So basically 21 bits, right? So 21 bits is going to be, so 21 kfps or kb kilobps, so 2.1 mbps. Basically you can also keep it in the bps part. You can also keep it in the bps part. So but if you can also turn it around in the mbps. So the output data rate is now how many frames are sending in one frame and what's in the size of the frame. The multiplication of the both multiplication result of this one will give you the output data rate. Okay. Now the question number E is asking us what is the efficiency of the system, and it is the ratio of the useful bits divided by the number of the total bits. Now we know that from using these 21 bits, among these 21 bits, only 20 bits are useful. Only the 20 bits are useful because they are carrying some original data. This is not my useful data bits, rather it's a synchronization bit which will give some kind of synchronization between the sender and the receiver. But these things will be ultimately deleted. These things will ultimately ignore once they have been synchronized. So my thing is that my useful bits, the number of the useful bits are now 20 bits, okay, and my number of the total bits using the useful bits and the non-useful bits, or the synchronization bits in here, is going to be the 21 bits, right? So how many bits will be there? So basically the question number E is more simple, more fun to solve. So basically the question number E is the ratio of the useful bits. We know the ratio of the useful bits is 20, and the number of the useful bits are 20, and the number of the total bits are 21, and there's a percentage. And if you do the percentage over here, you will find that this is the 95% usefulness, because the 5% was not there because you have been using them. You have been using them for the synchronization part. If you didn't use the synchronization part, let's say if you didn't use that synchronization part, if your slot would have been 20, and they all of the 20 would carry the 1 bits from each of the channels, so in that cases your number of the useful bits would be 20, your number of the total bits also be 20, so you could expect a 100% efficiency over there. But now we have a 95% efficiency because the 5% efficiency is going to be that synchronization part. Okay, so this is the solution for the question number 2. And I hope that if this type of the math comes in the exam, you can easily solve it. Just remember those formula. I've also already shared those formulas with you. This formula tables are available in the Google Classrooms. So basically you have to just memorize some of the formula, and you have to understand where the trick is going to be. What is the multiplexing unit in which of the formula? If you have the multiple formulas, what will be your, which one will be choose? That things you have to prepare yourself in. Now let us look forward to the second question, the second type of the question.